Have you ever really thought about what a piece of software does the moment you click Run? Today, we're diving into dynamic analysis to pull back the curtain and see what's actually happening behind the scenes. So, picture this. You've just downloaded some new, maybe simple-looking application. You run it, and for a split second, you might wonder, what is this thing actually doing on my machine right now? At first, everything seems totally fine. The window opens, the buttons are there, and it looks like it's doing exactly what you expected. No red flags, not yet anyway. But then, maybe you notice something a little odd. Your network monitor starts blinking, showing that this little program is talking to servers you've never heard of. You think, wait, why would a simple calculator app need to do that? Suddenly, that trust starts to waver, and it doesn't stop there. All of a sudden, you're finding strange new files tucked away in different folders on your system. To really figure out what's going on, we need a specific way to look, and that's exactly where dynamic analysis comes into play. To get to the bottom of this, we need to know how to look. There are two main ways to analyze software: recipe versus reality. On one hand, you've got static analysis. This is where you look at everything without running it. You're reading the code, checking the files, and looking at all the parts laid out on the table. On the other hand, you have dynamic analysis, which is all about watching the system while it's up and running. Let's try an analogy. Static analysis is just like reading a recipe. You can see all the ingredients listed, read all the instructions, and in theory, you know exactly what the dish is supposed to taste like. But dynamic analysis? That's like actually being in the kitchen watching the chef cook. This is where you see what really happens. You see them maybe swap out an ingredient or leave something on the stove for way too long. This is where the recipe, the plan, meets the messy reality of the kitchen. And that's the absolute key here. Static analysis shows you the intended behavior, but dynamic analysis reveals the real behavior. And trust me, sometimes there's a huge gap between the two. Okay, so if we're going to be in the kitchen watching this software cook, what are we actually looking for? During a dynamic analysis, we're really focused on a few key areas. We're watching for any new processes that start up or shut down and monitoring changes to the file system. Are new files being made? Are old ones being changed? We're tracking all the network activity and keeping an eye on system resources, like how much CPU and memory it's eating up. A lot of this behavior is going to be totally normal, but what we're really hunting for are the surprises. Those little anomalies are the real clues. They're what point us toward potential risks, or maybe some hidden features. Because when you boil it all down, this whole exercise is about answering one single powerful question. What is really happening here? So why does this matter so much? Dynamic analysis is a massive deal in a lot of fields. In cybersecurity, it's how we hunt for malware. For software developers, it's absolutely essential for finding those tricky bugs that only show up when the program is actually running. And for sysadmins, it's how they find performance bottlenecks. Now, before you get too excited, we have to stop and talk about the golden rule. This is a powerful technique, which means safety isn't just a suggestion, it is completely non-negotiable. Running unknown software on your main computer is like inviting a total stranger into your house and then turning your back on them. The potential for damage is just enormous. The only safe way to do this is inside a completely isolated environment, usually a virtual machine. You have to control its internet access and make absolutely sure there is zero personal or sensitive data on it. The goal here is simple. Observe the software's behavior in a controlled sandbox where it can't do any real-world harm. Beyond just safety, there's professional responsibility. It means you have to respect privacy and operate within legal boundaries. The fundamental rule is crystal clear. You never, ever analyze a system that you don't have explicit permission to investigate. Period. As we wrap up, remember, dynamic analysis isn't fundamentally about being some technical genius. It's about careful, methodical observation. So the next time you run a piece of software, get curious. Ask yourself, what's really going on here? Watch carefully, question everything, and always stay safe. What will you discover when you start looking a little closer?